we're busy with calculus and we're busy doing differentiation or finding derivatives. It's all the wordings that you must know. To find the derivative of this expression or this function, to do it the shortcut method, what would the answer be?
12x.
And how many marks would you get if you write that?
0.
That's just to help you. That's my shortcut method. So I know that this is going to be the answer. Then I've got to know the formula that says differentiation of 11 tends to be 0, x plus h minus fx over h. Okay? And then I taught you I would rather want you to do this little PC up front. Because it makes your sum less cluttered inside of it. Not always terribly, but it's a good technique. Otherwise, in here, together with all the other stuff, it can get quite chaotic. So, finding the fx plus h, you must know that I go back to fx, and everywhere that there was an x, there's now an x plus h. So, this must now read 6x plus h squared plus 1, and everything else that might have been in that expression. There was another x, there was another x plus h. So, to simplify, I told you you're going to find this very often, not in every one, but very often. You're going to have a bracket square like this, so know it. That is x squared plus 2hx plus h squared. And if you struggle and if you think you might be wrong, rather just write it out. So that my answer would be 6x squared plus 12hx plus 6h squared plus 1. Can I simplify that? No, that's it. Then I'm going to go in here and substitute that 6x squared plus 12hx plus 6h squared plus 1 inside of your formula. So the h is still there, and I'm short of the minus fx. So minus fx means subtract this whole thing. So that's going to mean minus the whole thing in a bracket, making this up minus. And making this up minus as well. And if it was a minus, it would become a plus. Then I also said to you a phenomenon to expect is if the original sum had how many terms? Then you'll find this phenomenon that 2 of them cancel out with 2 of the other ones as well. So what am I left with?
12x plus 6.
Okay, now why didn't I do from the start substitution of h with 0? Because it would be undefined, so you know you've got to sort out that h at the bottom has got to disappear miraculously in some way. So to do that, I'm going to have to take out a comma.
H.
What's left?
12x plus 6h.
Over
H.
h, making my problem disappear. Because I couldn't put in the h with a 0 unless it was not underneath the line. So the limb is still there. And please take note of your notation. That there's all the time still equals, all the time still limb, and that you don't put the equals in between here. That doesn't make any sense if you read it that way.
Yes, ma'am.
And then the next step, you can actually write just like it is there, and then only substitute the h with a 0, but you can do it now. The moment that it's possible to substitute, you're going to substitute. So you're substituting the h with 0, and your answer is?
12x.
Like we knew it was going to be. How many marks?
6.
5, more often 5. 5, maybe 6 if it's difficult, but this was actually quite straightforward. The other one was so easy that I gave you. Okay, let's do this one. First shortcut method will give me
Negative 3.
So the answer must just be negative 3. So to find it, now guys, if you didn't do that little PC at the top, it's fine. There's no rule that says that you must first do the fx plus h before you come to this sum. Because the sum was actually quite easy. It wasn't difficult. There wasn't lots of terms and lots of calculations and squares and stuff. If you substitute this x with the x plus h, there's actually very little to do. if you want to stick to it and say fx plus h is negative 3 times x plus h, the only thing you would have had is minus 3x minus 3h, and that was it. But that was quite easy enough to do it here, with minus 3x plus h, and then finally minus 3x minus 3h. Wasn't very much. So I'm substituting that in here now, and finding minus 3x minus 3h. But then minus the fx means minus of the minus will become a plus 3x. Still over that h that is bothering me, still with the limit tending to be 0, h tending to be 0. And if can I now cancel out what's happening here? One term and one term cancels out because of the one term being at the top, there's one of them cancelling out. And then what?
It's about an h.
Then you can just cancel out the h. Are you with me?
Yes, ma'am.
Because it's just negative 3h over h. So are you allowed to cancel out now? Because there's only one term you're allowed to. So this time, we didn't have to
Take it out.
factorize. Do you need to write that step? No. But that's what's left. And you can cancel out the h's. And now what? I'm saying go and substitute h with 0, but there is no h. So is that a problem? No. If I say x tends to be 3, but the whole sum is in y, it doesn't make any impression on the sum. You can't go substitute an h if there is no h, and the answer will just then be the negative 3, which we knew was going to happen. Okay, let's do another example of first principles. You don't do first principles except for the one sum that they say. Do this with fundamental principles, ground principles, basic principles. First principle is the one that they use most often, but you're getting the idea. Get the differentiation with some sort of principle, then you know it's going to be first principle, right? First of all, to check ourselves, what's this answer going to be? First, do the fx in terms of x without the denominator being underneath the line. I'm doing it shortcut way. So for the shortcut, what would that then be? Negative 2x minus 3. And there you would stop when you do the shortcut differentiation rules. We are not going to differentiate. So the answer will probably not be to the power negative 3. It'll be back to negative 2 over x to the power 3. I'm aiming that that's going to be my answer. Okay? So, a little bit tougher. But the principles stay the same. With a little bit extra because I'm busy with fractions that wasn't in the other sum. So first of all, go do your fx plus h. There's not a lot to do because it's that typical one that we know, or that one that we know is x squared plus 2hx plus h squared. Not a lot that's happened in it. But when I now go to my formula for the derivative, it'll be the limit of h, which tends to be 0, fx plus h minus fx over h, which I can never ever start with until I've sorted out that h there at the bottom, which is normally done with factorization. The previous sum didn't have factorization, normally. So now if I substitute that in, it's going to be 1 over x squared plus 2hx plus h squared, agreed? Then minus that with 1 over x squared. It was a plus, so it's now a minus. And everything over h, and the limit of h tending to be 0. Now how horrible is that?
Very.
Because there's 3 things on top of each other, which is something that you were taught long ago. Now, you might think, let's take the h to the top, it becomes h to the minus 1, but you still have to time it in. It's still at the bottom, it's still going to have problems for my denominator. This h, okay, let's not talk about that just now. What can I do to simplify this? What is the technique that you've been taught? Yes, LCD, because it's fractions, right? And the other technique about having a fraction over something else.
Take it to the top.
Let's me take it how to the top. Let's make it times, right? Instead of divide by h over 1, it's times by 1 over h. But this whole fraction here should still be there. But now I want to please get the LCD. What's the LCD of these two denominators? X squared. Okay, plus 2hx, that whole thing there, right? And times with x squared as well. Now normally we put a single number in the front, but you could have put it at the back, no problem. But the LCD is this whole thing times with that whole thing. What do we do with LCD? It's what you time at the bottom, you time at the top. What did I time here at the bottom? X squared. So at the top you time with x squared and you get x squared. If you time the bottom with the whole bracket, you've got to time that -1 also with the whole bracket. Gotta keep your wits about you in this one, eh? So we've got, this is LCD. LCD. Doing LCD. Getting the LCD of the denominators, timing at the top with what you timed at the bottom. It's a huge thing. Why can I still not substitute h with 0? It's still at the bottom, any which way you look at it. Can I substitute this x with a 0?
No.
Yeah, it's not going to make the whole thing a 0. And this one? Not a problem. That is the culprit that I've got to get sorted out in some sort of way. So what else do you think we should do? Yes, simplify. Time it out and simplify and see what happens. So if we do that, what's going to happen? The x squares are going to cancel out. You're going to have x squared minus x squared minus 2hx minus h squared. Only thing that happens there is the -1 is multiplied in. At the bottom, we have something that can be simplified, but I want to say, whoa, until you don't need it, don't do it.
Okay.
Because why would I want to simplify? Maybe there's something that can cancel out, and that'll only happen with factorization. So leave it as factors for the moment. So I still have x squared times x squared plus that whole trinomial there at the bottom, which makes things disappear. Again, how many terms? There was one term. How many cancelled out? 1 with 1. What else? What's my problem? How will I get rid of it?
Oh, you're gonna cross what? That thing. You're gonna
Time here with h over 1. It's not an equation. You can't time here with h and times where.
You're gonna times
Not
the
a
h
left-hand
at the
side.
bottom.
Sorry?
Times the h at the bottom and the 1 at the top.
Times.
Lem.
What's my process? Get the common factor, which is? It's actually minus, isn't it? But I don't care. All that's important to me is that I know I'm going to have this cancelling out. So my problem disappears. That's my goal. You must know that this is your goal. Even if you can take out a minus as well, don't do it. It's all about the h that you want to cancel out. If you do take out the common h there at the top, what's left? Negative 2x minus h. And at the bottom, shall I now time it out? Please don't. There's no rule for it. There's no reason for it.
Just
So it's x, but it's not wrong if you would time it out.
just in time.
But there's still h's at the bottom, guys. But those h's won't make the denominator 0. If I do substitute with 0, it's not going to be a problem. So can I now substitute? This thing looks horrible. But can I now substitute?
Yes, ma'am.
Don't try and simplify if it's not necessary. Your problem is solved. If you do substitute the h with a 0, what's going to happen? negative 2x plus 0, which you don't have to write. And at the bottom we've got x squared plus 0 plus 0. So that's all that's left. No problem that there's a 0 underneath the line, making the denominator 0. Is that the answer though?
No.
Not quite. I just have to simplify a little bit. How? Because when you time, you add exponents, x to the 4. When you divide, you subtract. So what's going to be your answer? Which we knew was coming. But this was a much higher level sum than the ones that we've seen. What made it difficult? Because there's fractions, and that you had to do the LCD and tip the thing. So it made it a little bit more difficult. But please focus on your aim. You want that h to disappear, and this is a very, very good technique from the start. That if you have over h, you can always say times with 1 over h, even from the start. So instead of writing it over h, you can say times with 1 over h. But the problem still remains that there's an x underneath the line. We do it here so that we don't have three things on top of each other. But the h is still at the bottom. And we've got to sort it out. And the solution for the sorting out was factorization. More often than not, it is factorization.